Okay, so in this video we're going to look at another case study building. This is the Dance Pavilion by Frei, Otto. Late 50s, I believe 1957 or 8. You can see that it's held up, so this membrane structure is kind of floating in the air. It's held up at 6 points by these really lightweight, very, very thin and light columns. Each of the column points up at the top are held back by 2 wires. The columns down below are held down to the ground with a pin connection so they can rotate. The lower points here are also held down by a series of 3 cables, 2 of which come down to the anchors of the 2 columns that are on either side of the point, and 1 more cable that comes down straight to the anchor that's being shared with the wire that's coming to the top of the column. So it's a really efficient, elegant structural system. You'll see that as we model it, all of these elements combine to form structural stability. The shape and its structural capacity is not possible without every single one of these elements working in tandem in order to give this thing its stability and form. So it's a good example for how, first of all, how to model something like this. Form finding is necessary, and it's also a really great example of a very clear set of components working together to form a stability through a dynamic structure. So here, all of the forces that are being applied to every one of these elements are working in tandem to find this equilibrium state, which is the ideal form for the shape of the membrane and for the length of the columns and so on. And yeah, this is just another photo of it here to get a different look at it. I believe it's still in use. I could be wrong about that. I think it comes down in the winter and they put it back up in the summer. But here's, you can see here one of the anchor points, the larger guiding cables that come up to the top. I mean, look at that. The column here is super lightweight, this kind of truss-like column. And one of the reasons that it could be so light and thin is that it's being supported and stabilized by these guide wires that come back down to points that are further out from the base of the structure. If these wires weren't here, the ones coming back, it would mean that this column would have to be anchored into the ground without a pin. There would have to be a deeper foundation here, and the column would have to be held at this particular angle, and it would have to be much larger. It would have to be probably at least twice as thick, and probably not trussed like this. I don't know exactly, but I know that it would be larger and much less elegant without these guiding cables that come back down to the ground to kind of hold everything in place so that this can be in compression and everything else is in tension. Okay, so let's get started on this. I'm going to post later after the tutorial. I'll post the Grasshopper file for this that builds it from scratch using only Grasshopper components. For the sake of the tutorial, I wanted to show you a way to model the base parts, let's say, or the parts of the system in Rhino first. So we'll model the columns, the cables, and a simple membrane that's flat. And we'll activate that membrane through Kangaroo. I think it's a good follow-up to some of the work that some of you were doing last semester, and also some of you this semester who are interested in membrane structures. This one's obviously a bit more advanced than the first one that we looked at earlier a couple weeks ago, but it builds on the very same, the same tools and the same logic. Okay, the first thing that we'll do then is we'll go ahead and build some construction work. You can see over on the side here I've got a set of layers: construction anchors, mass, outer, inner, and lower cables. You can go ahead and set those up. I'm going to work on the construction layer for now, and I'm going to draw a circle from the midpoint, from the 0, 0 point here, and I'm going to give this a radius of 45 units. I'm in inches right now. Of course, that's not going to be to scale of the building. As an abstract model, it doesn't matter necessarily what units you're in, so I'm just going to say 45 units. but it's probably best to work in feet or inches, just for tolerances. And I'll draw another circle from the center out at 32 units. And remember, these unit numbers, they're really just abstract values that I'm using to get the proportions more or less where I think they should be. I don't know the actual dimensions of the building itself, so if you wanted to really model it up as a one-to-one, you can do some research on it and find the drawings and model it more accurately. I'm just kind of eyeballing the proportions here for the sake of introducing tools. Alright, and now I'm going to use this circle to define the size of a hexagon. So I'm going to type in polygon. The number of sides up top, make sure that's 6. And the center is going to be the same center that we've been using. And by the way, I have my snap grid on here, you can see, so that I can snap to the same point each time. Sorry if that is unclear from the first 2 steps. But yeah, you want to make sure that all of these have the exact same center point. Alright, so to make that clear, I'm just going to put a point there for you so that we know which point we're using. So anyway, I'll draw the polygon, and I'm going to just kind of shift this out, hold shift, and intersect that with the first circle there, which will give us this. And then we can actually hide or delete this one, so I'm just going to hide that one. We don't need that one right now. I'm going to draw one more circle, and I'm going to go over here and I'm going to hold down my button, my left mouse button, and grab this circle 3 points command, and then click. Oops, sorry, those are the wrong points. I want to click actually the midpoint of each of these sides, like this. Yeah. So I want to inscribe the circle, not circumscribe the circle. Okay. And now I want to draw some construction lines so that I can start finding. So what I'm going to do is I'm going to draw a line from the center to the midpoint of each of the hexagon sides, like this. And then I'll just select that, type in extend, and then select those curves to extend out to the sides, like that. And then one more set of construction lines will be necessary here. We're going to have to come from each one of the corners and in, like this, finding some new intersections for column anchor points, which will be here. And then one last thing for the couple more things for the setup. I'm going to draw another circle from the center point again, and this one's going to be much smaller. It's only going to have let's say 4 units. And then I'll draw another polygon, which we'll need later, also 6 sides, and I'll inscribe that like this. Okay. And this circle again, you can hide that now. Also, just for clarity, what I'm going to do is I'm going to trim all the construction lines that come in toward the center there, so I can start cleaning this up. The next step is going to be I'm going to go to my anchors layer here, and I'm going to start drawing points, first of all here, and this is going to be where the guiding cables come down to from the column tops, the column top points. This is going to be the column bottom point, that intersection of the inner circle there with the other set of construction lines we drew. Like that. And that's it for anchors in terms of where things touch the ground. Alright, so let's go to our perspective view and let's start giving this thing a little bit of height here. So we're going to take this hexagon and we're going to move it vertically. So I'm going to type in move, and then I'm going to click vertical yes up top here, and click any one of the points and just drag this up to, I'm going to say 15 units. And this might be a little low, but I think it might work for these proportions. We could move it up later if we think we need to. now we have something like this. And now we can start connecting some dots here to start drawing in our building structure. So I'm going to go to Masts, the red layer. I'm going to start drawing lines from these points down to their corresponding intersection point that we found earlier, like this. Alrighty. And there's going to be our, representing at least our, the mast columns that that hold up the highest most points in the membrane. Then I'm going to go to my outer cables layer here and start connecting dots from the top of the mast to the outer ring intersections. And you could draw this, actually I'm going to start that over because you could draw this all as a polyline like this continuously, and it will just split it in Grasshopper. So we can just draw like that, going around. The circle to the end there. Okay, so those are our outer cables, and they're probably a bit longer in reality, but let's see how it goes. And let's see, we need another set of cables, so let's do our inner ring. Our inner ring we're going to model in a similar way, but these are going to go from the bottom point of the column to the midpoint of our raised hexagon. So here what I like to do is I'm going to go to the inner, I'm going to kind of like rotate my view from the center of the object, see it from this view, click on the bottom of the column there, and then click to my midpoint like that. And you can go ahead and go all the way around just like we did before. So from bottom to mid like this. And it's very, very important that you click exactly to the midpoint. So make sure your O-snap is on there. And we'll talk about that a little later. Okay. And then there's one more set of, one more set of cables. And now we have to draw a cable from here back down, right, to hold this point taut. So we're going to go to the lower cables layer and go from the point that we just drew there, the midpoint, back down to this outer. Sorry if you can't see that. Maybe I should change the color, but there's a purple line that's going from this point down to there. And these are going to be separate. There's no polyline here because it's not continuous. Again, making sure that you're snapping. If you think that you might be a little bit off, the simulation later will fail. So make sure that the lines are actually touching at the exact same point that we're going to use to anchor them down. Okay, now there's one last thing, and it's going to be the membrane itself. So I'm going to make a new layer, call it the membrane, and we can leave that black. One thing we got to do to make this a little easier is bring this center hexagon up also 15 units. So I'm going to move that up. Move it from wherever point vertically the same number of units, so 15 units upward. There we go. Okay, now if it makes it any easier for you, you can go ahead and lock these layers or turn them off. Maybe I'll do that for myself as well. And so I know I'm not snapping to anything that I don't want to touch here. And I'm going to kind of look at the view this way and just start drawing some mesh faces. So I'm going to go to Mesh, Polygon Primitives, 3D Face, and I'm going to just go clockwise around the set of 4 points that correspond like this. Let me turn that on to ghosted. Right, so you can start with some Mesh, Primitives, 3D Face, starting with the inner hexagon, connecting around like this. And here it may also be helpful to turn off your grid snap because it's, you know, it's kind of dragging a little bit as I click around. And this you have to do very carefully. The other way you can do this is to take one of these and rotate it as a copy. So you can rotate copy yes. The center of the rotation is going to have to be the center there, so we can draw a center point. And then click any one of these corners and just, you know, copy those around like that. So that's a quicker way of doing the same thing. And if we drew everything right, these will be connected perfectly at the corner points on both the outer and the inner. If there's any discrepancy there, if there's any sloppy modeling, you'll end up with issues. And we'll talk about that when we get into Kangaroo. So I'm going to select all these faces now and just join them together into one mesh. It's saying it's just jointed. That's probably going to end up being a little bit of an issue later. But we have a component that you just installed that will help with that. Alright, so let's turn on these. Let's get these going again. Turn on all those layers again. And we can start setting these things very, in an organized fashion into Grasshopper. Alright, so let's open up Grasshopper. Go ahead. I guess I'll, yeah, well, you already know where their layers are there, so I'll just do this like usual. So I'll bring in my mesh first, so let's bring this in. Oops. So I'm going to go to mesh and bring that in. Actually, I'm going to turn on the full names, and that'll be helpful later. So you can just select your meshes here, and there's that. And then we can, as we go, we can turn off. I'm going to go to my default layer, and I'm going to start turning off layers in Rhino. So I'm going to maybe do that a little bit later. All right. The next is going to be our anchor points. So for this, I'm just going to grab a point parameter. I'm going to type in SCL point PT, select all the points on screen, which I know are okay to grab, and I'm going to set them in to this parameter here. Okay, so all those are in. And then I'm going to go down the line and put in all my line objects. So the first one will be actually, to do this a little quicker, we'll select layer. All right, select layer, masts, set the masts in. And as we do this, you should name your components here so we know what's what. These two are pretty self-explanatory. So let's select layer, outer cables. We get the idea. Okay. Keep going. These are our inners. Okay. Okay. So we got all of our objects in. I believe that's all of them. And in that case, I'll start turning off some layers over here. And there we go. So there's our kind of initial Grasshopper setup. And now I think, you know, it might be wise. I mean, of course, you should save your Rhino work always. So you should save this. But also, what I like to do sometimes is to make sure I just internalize all this information, all this data here, because you know, if down the line I lose this file, or you know, the Rhino file, or if later on in my process I forget, you know, to internalize this stuff, and then I end up losing the Rhino work, I have to remodel it, and that can get a little frustrating. So it's good to have them both, you know, kind of locked in, and you can't really lose your work. Okay. Alright, so the first thing we're going to do now is we're going to start, we have to give this mesh some subdivisions, and I'm going to move somewhat quickly through this next part because it's some territory we've covered. But the first thing is going to be to use Kangaroo Subdivision to give this some more points. So we'll go to Mesh in Kangaroo, and we'll go to Refine. And I'm going to turn off previews as I go. You know the drill here. So Mesh, the level of subdivision we can put in a panel, and I'm just going to put in 4. We can go pretty high on this because we don't have a lot yet that we're working with. It's a very low res mesh to start, and we're going to add a lot of detail to it so that it simulates very smoothly. Alright, so now here's where we have to use that component that we just installed. So we're going to go to and this is one of these things that maybe I should show you first how it fails, and we can talk about why we have to use it. So let's go to Kangaroo 2 first. We'll go over to the Mesh tab again. We use Combine and Clean to see if we could, make sure that ensure that this mesh is doesn't have any open seams, any kind of naked seams. To do that, after it's been kind of combined and cleaned, we can go over to Mesh again, grab this Naked Vertices component, and see what we get out of that. And right away I like to turn that one off because I don't want to see the ones that are on the inside that are clothed, so to speak. I want to see the ones that are naked and exposed. And here we can see that regardless of this component, we end up having an open seam here. And this is just due to some rhino tolerance issues with mesh modeling. It's very common and can be a little frustrating. So a way around that that I've found is to simply use, so we go to Mesh, we've installed this component here, the Mesh Weld Vertices. This is the best one that there's a lot of different, or there's not a lot, but there's a few components that are like this one from various add-ons. This is the one that I think is the most, works the best. So let's turn off some previews as we go again, and we'll use this component here, and then we'll try again. You can see that those points now disappear. So we know now, because we're able to set a custom tolerance here, which is very, very small, our weld threshold is forcing any points within 0.01 dimension away from one another to be the same point. So it basically just welds them together to form a single point, as opposed to having a series of naked points here. Alright, that's super important because if we had gone ahead and simulated this mesh, we'd have an open seam here and it would rip. And basically it would give us the effect of tearing the membrane in half. Okay, so we can leave this here as a tester. We don't really need to see it anymore. And this is now our mesh here. So actually, what I'd like you to do now is to just, and you can see that the mesh got a little darker, and that's because they're facing the wrong direction. So what we could do is route this directly in, and then we'll use the Combine and Clean later. So we'll kind of swap those two components like that. You could turn this one off, and then turn that one on. So now at least this component here is useful for cleaning it up even further and making sure that our mesh normals are facing toward the sky and not toward the ground. It's a really minor little thing, and it's more of a best practices scenario than it really is a necessary one. Okay, moving forward, there's a couple more things that we've got to do to set this up. So let's work with the mesh still. So let's go over to, while we're in the mesh tab, I'm going to grab this mesh edges component here. And this is going to separate the outer edges from the inner ones, which is very useful because we're going to have to set different forces on those to get this to get the shape to come through in the way that we see it in the case study. And there's a little bit of a process here to separate out. The other thing we're going to have to do is separate out these inner lines in here, the edges out here versus the edges out here, because that too will need custom strength parameters in order to shape the membrane appropriately. Okay, so let's go over to curve. I'm gonna first of all figure out. I'm gonna use this little trick here to figure out how long. I'm gonna measure how long the edges are that are coming out of here, and then I'm gonna use a tolerance check to see if they are longer or shorter than a certain value, and I'll use that to separate the two sets. So first, let's go over to set and sort. Alright, so set tab sort, and the keys that we're sorting are the lengths themselves. The objects that we're sorting, or the values, are the lines themselves, right? So we're going to do that. And this is going to sort them from short to long. And then we could go to math here and grab a smaller than component, and we're going to drop the keys in here. Our second number is going to be a slider that we can use a default slider for that, I believe. And then we're going to go over to set sequence and call pattern, because this is going to output a true or false, whether or not it satisfies the criteria set up over here. And we're going to take the list out of A, not out of keys, but out of A, into that call pattern component, and then use the results of that call pattern to select or deselect certain objects. So I'm going to turn this off for a second so we can see what we're working with here. And it looks like, you can see it turning green there. It looks like now we've been able to separate the outer edges from the inner ones, especially now if we copy and paste this component and we right click on call pattern and invert that Boolean pattern, so every true becomes false and vice versa. So now if I select this, you'll see that just the outer edges are being selected, and this is going to be just the inner edges. Okay, and this value can, can increase or decrease. It doesn't really matter. Once it's satisfied its criteria and it doesn't reach the length of these, it'll separate the two. Does that make sense? Okay. The other thing that I should probably mention is that I changed my display here to drawing the full names. It's kind of a middle ground between, the icons and knowing what the icons need. Personally, I prefer the icons. Some of you might prefer the names themselves. So maybe the middle ground is the full names. So in case it looks different than our earlier tutorials, that's why. I'm sure there'll be some questions there. And while we're on the topic of the mesh here, while we're working with the mesh, our interior edges is something also that we are going to need to work with. So we're going to pull these out as a separate thing and pull it over here so that I'm organizing my file. And when I work with Kangaroo, I think again I stress that my file is quite organized, because especially for this one we're going to need to set a lot of different custom strength parameters to many different elements, and we're going to want to know what's what when we have to make changes. So what I like to do is start to group things and label them. So this is going to be our outer mesh edges, and that's good enough to figure out what's inner and outer, I think. This one is our inner mesh edges. Okay. Well, to make that, I'm just going to say inner mesh. Fair enough, right? We don't have to call them edges if it confuses you. And then we're going to, let's go to Kangaroo 2, and we're going to set up something that we're going to have to copy and paste a few times to start setting custom spring goals here. So we're going to go to goals, line, and length. We're going to need a lot of these, but there's going to be a little bit of a setup before we start copying and pasting. So what we're going to do is we're going to go back to curve. First of all, we're going to measure the length, and we're going to multiply that length by a value between 0 and 1. All right. So I'm going to go to math, multiply this length between 0 and 1. And the lines themselves can come into here. The length is going to go out of the result of the little multiplier, and I'm going to leave that at 1 as we get started. The strength here we can leave by default at 10. We'll talk about that later. Alright, so we've got our goals set to our inner mesh lines, and this is going to basically produce the kind of internal stretch or tension in the membrane itself. So this is going to be the internal force that these external forces act against, if that makes sense. So think about it like a tug of war. This mesh here is going to be fighting the pull of these outer cables, and because it's radial, they all kind of, they all sort of balance themselves out. All right. So let's go ahead and copy, let's see, I need 3, 4, at least 4 of these. So let's go ahead and take this set of things and copy and paste these a few times. But before I keep going, I'm just going to disconnect these lines here so that when I copy and paste this, it's kind of, it's separated, which might be a little easier on the eyes so you don't see all those wires flying around. So I'll take a few of these, maybe I'll just copy 3 of them for now and see how that goes. Okay, and actually 2 of them we can lift back up over here because each of the results coming out of the calls are going to need custom length goals, so we can do this. All right. Now let's spend a second organizing that. So I'm just going to make this look pretty, keep it all nice and clear so I can follow the trail back down and around. All right. And this is going to be the next set, and I'm going to copy and paste a couple more of these. And we're going to add a component to these 2 as we bring in our other elements. So let's go over here. Let's start looking at this stuff. I'm going to bring some of these things over so I can start working with it. And the first one I'll work with, we'll leave the anchors back for now, but the first one I'll work with is the mast. So we're going to go ahead and take these in. And this one's a little different. So with the mass, I actually don't need the multiplier. And I don't even need this at all. With the mass, actually all I need to do is pop these in here. You can throw this in there to ensure that they don't change their length. And then what we want to do is increase the strength of this one quite a bit here. So I want to make sure that this, I'm going to go to 1,000 on the strength here, because I don't want our columns to buckle. I don't want them to change length. They need to be standardized as a set length. The cables, on the other hand, I actually want to change their length. So now we have a set of cables here. The lower cables are the ones that don't yet, they're not polylines, so we'll wait on the polylines. So let's work with the lower cables because that we can route right directly into our little copy and pasted setup here. So let's go ahead and do that. Lower cables. Good. And now for the outer cables, what I got in the inner ring, what I have to do, because these are polylines, I'd like to make these, separate these into segments again. So I'm going to go to curve, explode, and you're going to find all the segments coming out there. So the segments themselves can go into the length component, and then the segments go into the line input there for the goal. All right. And I'm going to do the same thing, copy and paste this chunk here, do the same thing for the inner ring. Yep, good. The anchor here, we can put over here maybe. This one, we're going to go to Kangaroo 2, grab the anchor goal, and that's done. It's already at a high strength by default. Okay, now I should have 8 goals coming in. Let's find out. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So it looks like we're ready to start setting stuff up. To do this one, what I like to do, because what we're going to want to do later is in post-processing, after the simulation, we're going to want to make sure that we can identify which of these lines coming out are the cables versus the masts and so on. To add different line weights and so on to it, it's going to make your life a lot easier. So what I like to do is head over to Sets, go to Tree, and Entwine. All right, so we can start to place the each one of the goal components can go into one of these branches, and we can route the result into the Kangaroo solver. And that said, we should also bring in the mesh itself through and into the simulation, because it's good to visualize that too. So I'll go to Kangaroo 2 again, grab this little light bulb show component, and the mesh that we're grabbing is the one that we've extracted our information from, the one that we extracted the lines from. All right, so I'm going to do that, and that's going to be the first one because I want to be able to find that one pretty easily later. So that'll be the first output. Then we can go down the line. So here, let's add a bunch of, so zoom in, find the little plus button there, and go ahead and add a bunch of outputs. And let's just go ahead and down the line here. So we got 1 spring, 2 spring, 3 spring. I'm going to keep putting the springs in, and then I'll wait on the, so I'm going to organize it by cables first. Alright, and then masts, and then my anchors. Alright. And now we can, what's nice about this is that if we have to disconnect any, we can simply disconnect it from the entwine and not from the solver, which sometimes is a little nicer and a little faster. Alright, so let's grab a solver. We're going to use the regular solver here, fast one. I'm not going to plug anything in yet. First thing I want to do is make sure that I've got our true false here and our button. Very nice. Alright, let's go ahead and plug that in. Now this is going to happen. You're going to start seeing overlapping geometry. So what we're going to do now is turn off the mesh. Okay, turn off that preview. And it's a good thing now to start turning off all of the inputs. Alright, because it's going to get a little chaotic later on when we simulate stuff and everything is shown. So make sure the inputs are off. You can leave the anchors on, that's fine. That's not going to get in the way. And there we go. So everything basically off to the left of the sliders needs to be turned off. The goals themselves can be left on because they don't show anything. Okay. So I'm going to go ahead and run this thing. And nothing's going to happen yet because I haven't yet added any forces to any of my sliders here. So what we're going to do is we're going to find the inner mesh one and start playing with that first to see what happens. And yeah, we're going to start to, as we start to add strength to, membrane pull, if you will, or as we start stretching the membrane and giving it some strength, you can see that it's acting on the other objects on screen. And actually we still have a component on there. There it is. Turn that one off. And what this is doing is saying that the membrane itself is stronger than the cables that are holding it back. Right? So you know where this is going. What we're going to do is we're going to start changing our slider values to find equilibrium here. But before I do that, I want to try to clean up this visualization as well and get rid of these points. All right, so let's leave it kind of messy for now and not worry about it. Can reset that. And let's look at the output here. The output, as you'll notice, is the same structure as the input over here, right? So that's pretty nice. So it's all organized for us. So what we can do is kind of take this. First of all, I want to clean out any of the, this is a good habit too, working with Kangaroo. Turn off the solver, enters its preview. Click on remove empty for this component here and just go to true. Sorry, that was in sets, tree, and clean tree. The clean tree component is going to get rid of things that are zeros or nulls, and sometimes that comes out of the solver naturally. So this will clean up our numbers a little bit. Looks like actually it was already pretty clean. So that's probably redundant, but anyway, good habits. And then I'm going to go to explode tree over in the same tab there, and I'm going to take this whole thing apart piece by piece here. So I'm going to add as many outputs as I had inputs before. Alright. And then go to parameters, and we can start putting the proper, so here's our mesh, so we'll put that into a mesh tab. This is a bunch of lines, so let's figure out what they are. Okay, it looks like that's our inner edges, in case we need those for whatever reason in post-production. Right? That might be nice for profiling. I'm going to turn those off for now. The more lines coming out of here, so let's put those into a curve component. This is all of our inners, right? So this might be good for also drawing. What do we got here? More lines. This looks like it's going to be our masts. Yep. Nope, the inner cables. So I'm going to start lumping things together. So this is going to be our cables. And it looks like these are all going to be cables here, sure. So we can give all those the same color, same line weight, whatever you want. So here's all of our cables. Nice. And the last one here is probably going to be the masts. Yes. All right, cool. All right, now let's start giving this thing some previews to make it look nice. So I'm just going to go to Display, Geometry here, Custom Preview, and I'm going to make this. And you guys can play around with this, you know, with whatever you like. I'm going to give this a kind of a little bit of a translucent white color, and maybe keep it simple with the cables. Well, now I'm going to make the masts black like that. Yeah, that's pretty cool. And then maybe I'll make the cables something else. Maybe, I don't know, blue, just so I can distinguish those. Okay, good enough for now. We'll go back and make some more custom adjustments later. Alright, so now the thing is going to be to set these parameters so that they actually work. Right now we've got, and it's kind of fun to play with this. So before I give you the solution, I'm going to let you guys just go ahead and play around. Which one are these? The outer mesh edges, yeah. And we may have to actually add some strength to some of this stuff. But let's see. Yeah. So here I'm actually strengthening the membrane. It's giving me worse results. I can start pulling back, strengthening some of those cables. Here's the lower cables, the ones from here being pulled. You can see that it's really stressing the mesh there. Let's start yanking on some other stuff. All right, you can see that the columns are rotating in space, right, from that anchor point as if they're on a pin connection. That's an accurate way of modeling this, because these columns in reality are on pin joints. Same with the Munich Stadium. It's important actually that these kinds of structures are on, if they're going to be held back with wires like they are here, that they're actually on pin connections and not set to a particular angle, because the structure is able to move a little bit when it's loaded. Okay. It's fun to kind of play with these to watch it fail. If you go too far, it'll fall. And you can always get it to pop back up again. So it's good times to play around with this a little bit. I'm going to start by solving this first. I'm going to start by the mesh edges here. And I think these are our inner ones. Yeah. So the first thing I want to do is make these really strong, because this hole is way too big. We know that the oculus is much smaller than this. So what I'm going to do is I'm going to set a strength on this one, a custom strength, so that it exceeds the strengths of the others in the system. So this, I'm going to just crank that up, and then I'm going to turn that down to 0. I want this to be at its maximum, kind of pull strength with regard to, how it relates to all the other forces. So now we basically, because we're forcing all those lines to actually hold they're actually holding quite a bit of strength in the system. It's forming this really nice circle here, and it's equalizing those forces really nicely in the middle. And some of the other numbers that I've got in my test file here, in terms of the outer cables, and we know that those are out here, outer cables. Yeah, something at around 0.6 seems to work on my screen pretty well. In terms of the angle that is at, seems like a pretty natural angle for this to be. Obviously you don't want it to be like this, that makes no sense, and you don't want it to be like that either. Right? You want it to oppose the forces from the mesh, from the membrane, but you also want it to keep it as vertical as possible, so that the compression, that load path is forcing this nicely down into the ground. Okay, so I'll leave that at around 0.7 or something like that. The inner cables, can drop these quite a bit actually, because this is where we're going to start getting that form to emerge in the in the case study, right? So it's this point down here we're starting to dip, and yeah, it's getting pretty close already. You know, overall I think our height's a little low, but you get the idea at least. So I'll leave that around 0.4 or something like that. And again, the values on your screen may differ from this. I think it does depend sometimes on the computer and other things, but hopefully you're getting results similar to mine. If not, I'm pretty confident that if you played around with the sliders a bit further, you'd get this to work. Let's see, let's go back up to this one here, and we can really strengthen those. So here we're actually, you can see what we're manipulating here is actually the shape of the outer edge. You know, if we do this, it stretches the mesh quite a bit to this point, which is a little extreme. I mean, maybe it's okay, but I'm going to turn that in a little, and then I'm going to take another good look at this angle and go back to our outer cables force and actually reduce that even further. Yeah. So that gives us a little bit of a more stable angle, at least intuitively. And then we can even pull these down a little further if we want. There we go. Very nice. Okay, and what do we got here? This is the lower cables. We've already started to manipulate that a little bit. Yeah, that set seems pretty solid at around 0.5, and you can adjust this as you see fit. Let's go to the top view. I think that actually looks pretty close to some of the drawings I've seen of this building. I mean, we can even increase that a little further, maybe down to 0.4. Give that a really nice, because we want to be able to see that this is being pulled outward and not just downward. So this roll, the roll of that cable there actually has more to say than the roll of these inner cables there. And that seems to make some sense. Our side view is looking really nice, very stable. Yeah, so I think that's more or less it. There's of course other, you can play around and see what you can do if you went back and changed the height of the mesh and the length of the cables. You may have to make some different kind of adjustments to get the thing to find such nice equilibrium. But you get the idea that this is now really it's a combination of all these different forces at play to form this object here, to actually make this form. One thing also to mention that if you change the resolution of the mesh, you will have to reset. And actually, for some reason, that breaks it. Oh, this will have to be also changed, I think. So let's turn these on, and we may have to. There we go. So once that's updated, we can go ahead and reset, and now we have a lower res version, if you will, of the same building, the same membrane, stabilized membrane structure, and it has less lines. So this might make for a different kind of drawing, or maybe even a better drawing. Or it could even start to set you up for panelization ideas, things like rationalizing it into construction parts, whatever you think. But just to say that if you do make a change to the base topology here of the mesh, you do have to make some adjustments down the line in order to reset it into Kangaroo. And the other thing is, now that we've changed the density, this mesh is probably a bit stronger. The higher the resolution, the more elastic something's going to be, and you might want to then change the angle again here. So I would suggest that this number gets reduced even further a little bit to balance it out a little bit more. All right, but let's pop that back up and turn it back to where we were before. And yeah, things are going to get weird for a bit. And we should be able to reset that. And we're back to where we were. All right, very good. The last thing I wanted to show was that you can bring other things in through Kangaroo. This is a minor thing, but what I like to do a lot of times is, like for the anchors, for example, I really like to show the points as a fat dot. So I'm gonna grab one of these from the display tab and change its size. And the other thing we can do is take the endpoints of, you know, everything that's touching the mesh, all the cable points that hits the mesh. So the first one is going to be the mast endpoint. So I'm going to go to curve here. I'm just going to grab that endpoint, make sure it's the endpoint. Nope, it's the start point. And then I'm going to route that in. I'm going to put it up here so I can find it later. And then another one is going to be the, let's see, where's the, yeah, the inner, nope, the lower cables. Let's find the lower cables. Where are those? There they are, nice and close to all the rest. And let's find that point. And it might be the end. Looks like it's going to be the start again. All right, I'll put this up here as well. I'll turn these off. And then what I'm going to do for this one is go to Kangaroo and grab one of those light bulb components again and start putting all of these, well, the anchors you don't have to necessarily because they don't move. And then we can add another input here, put the light bulb in there, and that'll go orange until we add another output. And now the output of this is going to be where those points move to, which is pretty nice. So now I can simulate this all day and make changes, and the points will be will come along for the ride. So let's do this. Make that blue or something, so we can make it, yeah, pretty cool. And again, just to demonstrate that, I'll just kind of make a change to the outer cables here so you can see it move around, and you can see the points are now being updated along with the rest. All right. Now we can get it to fall over and pop back up again. All right, so I think it's a good example for, again, you know, like making sure that you're setting up your work in Rhino very carefully to try to get you know, so you should be somewhat conscious. I guess my point is that you should be somewhat conscious of how the structure works when you set up the, you know, how things are going to be pulled back and at what angles is kind of an intuitive thing. And as you get some experience with playing around with forces on screen and even in physical modeling, you know, you can kind of gain that intuition. And from there, it's just you know, adjusting these abstract numerical parameters in order to get a result that's very similar to you know, the form at least of how the building is actually going to look in reality. And from here you can say at least that the form that's being produced here, this mesh form, is one that's a result of physics-based simulation and is perhaps not fully engineered just yet, but still on its way to being, it's at least much closer as a representation, as far as a representation goes, of the way forces are going to travel through a membrane. And what's kind of required in order to get that to work. For example, the distance between this anchor and that anchor. You know, you have a much better idea instead of guessing in terms of what the overall footprint of this building is going to need to be. And that's really important if you've got a constrained site condition. So getting this kind of feedback through simulation and form finding, and that, you know, from that point of view, is also very important. Plus, it just makes for a much nicer and much more accurate you know, drawing of a structure like this. Okay, that's it for this one.